So the next theorem is the loop method of analysis, or it is also called loop current method or Maxwell's circulating current theorem, based on the scientist Maxwell. Okay, so if a network with several sources, it can be voltage sources or it can be current sources, and several sources means two or more than two sources we are talking about. Okay, and if it has more than two nodes, then the current can be calculated with the help of this theorem. Okay, so curved arrow representation of current is there in a closed loop. Okay, curved arrow means it can be clockwise or it can be anti-clockwise, but the direction of the source and current is generally taken positive for clockwise direction. Okay, if possible, we are required to take the clockwise direction, but there is nothing to worry about it. Even if you take the wrong direction of the current, the end result will be that the current will assume the negative direction, negative value. Okay, so if it is having the negative value, we can at the end say, okay, the direction is not from LHS to RHS, it is from RHS to LHS. Okay, that is hardly makes any difference. So after pointing out the direction of the current, we apply KCL and KVL, and the number of independent equations is equal to number of meshes, or you can say the number of unknown values is equal to the number of equations, and we can solve to get the values of the unknown values. Okay, unknown parameters or unknown physical quantity, whatever it may be. Okay, so let's begin with the, so everyone is clear about the steps which are to be followed in the Maxwell's current theorem, circulating current theorem. Okay, if the steps are clear, then we can move further for numericals. Okay, so have a look at this circuit which is given. Here we are to calculate the current in each branch. Okay. Just have a look. So here one voltage source is given, one current source is given. So in the first loop, based on the positive direction of the source voltage, we can assume the clockwise direction of the current as positive. Okay, and in the second loop, we have seen that current source is given. So the direction of the current source is pointing upwards. So we have to take that direction of the current. Okay. So in the second loop, it will be the anti-clockwise direction which is taken as positive, and in the first loop, it is the clockwise direction which is taken as positive. Okay. So in the first loop, when we apply the KVL, it is 10I1, okay, plus 10 ampere current is coming from current source and I1 is current. Now they both are merging at a node and KCL is applied. So when the KCL is applied, the current I1 plus 10 is going in the resistance 5 ohms. Okay. So the KVL for the first loop is 10I1 plus 5I1 plus 10 is equal to 100. So one equation, one unknown I1 can be calculated as 3.33 amperes. Now we have to calculate the current in each resistance or each branch. Then for 5 ohms resistance, it is 13.33 because 5 ohm resistance is receiving the current I1 plus 10. Okay, 20 ohm current is receiving the current 10 amperes from the current source, and 10 ohm resistance is receiving the current from I1. Okay, so this numerical is clear to all. एकता बेटा clear है ना?
Yes, sir.
So this numerical is having 3 voltage sources or battery source. Okay, so we have to apply same KVL and KCL to get the values of the unknown currents. Okay, so what it needs to be taken care of in these type of numericals is the polarity of the battery source. Okay, so when the battery sources are in series, when they are in parallel, or when they are in series, and when they are in series, the voltage adds up. But if they are not, their polarity is such that is different from the source battery, then their magnitude will be subtracted. Okay, this thing is to be taken care of in this numerical, else nothing new in it. Okay, similarly, as in we can see in the first loop, similarly we can apply the KVL in the second loop as well. So the current is flowing in the upward direction here, I2 current. Okay, and here it is flowing here. So when we apply the KVL, we begin with this 3 ohm resistance. So 3I2 plus current is flowing here. So 5I2. Now when the current is following this path, the current which is flowing from B to E is I1 minus I2. But here we are talking about the current which is flowing from E to B. Okay. So minus 6 I1 minus I2. Okay. So again, if we focus on the polarity of the battery, 6 volt battery is bigger magnitude and current is flowing from this positive terminal of this source in the upward direction, and the polarity of this 2 volt battery is not same as 6 volt battery. So again these 2 voltage batteries will oppose each other and the effective voltage will be 4 volts only. Okay, clear hai?
Yes, sir.
So we can also do one thing for the clarity or solving the circuits further. If we are focusing on first loop or second loop, we can also altogether replace or remove the small magnitude battery and replace the bigger battery with the effective value. Okay, if we are having confusion, and if there is no confusion, follow the similarly. Okay, so here there were two loops, two equations, two unknowns. We will solve these equations 1 and 2 to get the desired values of current. Okay, now let us focus again on this problem. So this problem is having the voltage source and current source. So first of all, what we are required to do in this problem, we have to determine the current values I1, I2 and I3 and power developed in the 10 volt source. One 10 volt battery is given. So we have to calculate the power which is developed. Okay. So first of all, we will assign the nodes to the circuit. Okay. So sometimes you may also give the letters to the vertex of the diagram, but that should not be confused with the node. Okay. For example, in this figure, we have seen that there are three boxes. Okay. So when we name them, we can name that A, B, C, D, E, F, G, N, etc. That is fine, good enough. But we should be clear that out of these A, B, C, D, vertex, etc., which are nodes and which are not. Only those vertex can be classified as nodes in which there is current distribution. Okay. For example, current distribution is taking place in the node A, N, D, F only. Others, no current distribution is taking place. For example, if we talk of B and C, this is the same branch which is having a resistance and voltage source. So same I2 current will be flowing through both these nodes, which are not nodes, which can be classified as vertex only. Okay, these are, you can say these are dummy nodes. Okay, so first of all, we will do the KCL, apply the KCL in the node N. So I1 minus I2, and first of all, we will also assign the clockwise direction of the current in the loops. Then at node N, what is happening in node N? One important point while we are naming any mesh or loop is that we have to start from any node and terminate at that very node only. Okay. For example, in this first loop, we are starting from this A, going A, B, C, D, N, and again A. Okay. So, first of all, we will apply the KVL here. So 2 I2 current, this current which is flowing, and then 6 resistance, 6 ohm resistance is given here into I2 minus I3 current, and this 4 ohm resistance. Current direction is opposite, so minus sign is this, minus 4 I1 minus I2 is equal to 2 volts. Why 2 volts? Because in the first loop, there is only one battery source. Okay, now we can talk of the second loop, which is the outermost loop. Okay, we are talking of A, N, D, E, F, G, A. Okay, so when we are taking this external loop, 2 ampere current source is not being taken. So we will apply the KVL here. So now this I1 minus I2 current is positive because its direction is same as of the loop which we are talking about. Okay, minus 6 I2 minus I3. So now this 12-volt battery is there and here 10-volt battery is there. Again, we can see that the polarity of these battery source is different. Okay, so battery source can be either written as this or in this fashion or in this fashion as well, that you can draw a circle and mark positive and negative on it. Okay, so this is effective voltage is 2 volts. So when we solve these equations, question number 1, 2 and 3, we will get the current I1, I2, I3. Okay, so when we get I1, I2, I3, what will be the voltage or the power developed across the 10-volt source? This is the 10-volt source and the current which is flowing is I3. So I3 is 3 amperes. So we will get the power developed as 30 watts. Okay.